Great. So a quick word about Zühlke. Welcome to our premises here. We're a global company with offices in 17 different places, and we enable transformational change in our clients. There's some facts and figures. You can find all those on our website. But the main thing is to tell you about some of the stories of things that we've done. You probably remember the COVID-19 app on your phone, which enabled proximity detection and therefore warned you if there was a likelihood you might have been infected. We basically devised that. We did some user requirements research. We did user experience design for Android, iOS, React and TypeScript. We conducted device trials. We did the mobile development and the rapid approvals through the Google and Apple API review bodies. We then implemented the whole thing in AWS serverless, and the first version was out in 8 weeks. That was a colossal effort by over 100 Zühlke staff from all over the world. We then continued to test and monitor the application and operated it for a few months before handing it over to another service company. At Zurich Airport, we did an enterprise-wide, flexible digital data platform which unlocks the power of data for the airport and all of its partners. As you can imagine, every airport has hundreds of franchises. This allows them to impose data governance and exchange data securely. There's a lot of IoT involved. It's all deployed into Azure. We integrated a lot of heterogeneous systems, some in the cloud and some on premises. And we provided self-service business intelligence and data science and enabled knowledge transfer between the partners. Finally, just another example, a university hospital. They have disease classification coding bodies, that basically expert doctors that look at medical reports and say, well, it's most likely to be caused by this. And we were able to provide a machine learning prototype that assists those doctors in about 3 weeks. That convinced them it was so much a multiplier for their forces, as it were, that they commissioned us to do a full implementation over a period of 4 months. They now have a data science team and the infrastructure to support it, and everybody agrees it speeds up the process. So I'd like to hand over now to my colleague Istyak, who's in Munich, to tell us about the specific example that we want to talk about tonight.
This brings us to the point where in the executives' agendas in different companies, where the top priority that they have at this moment is agentic AI, and also in their list they also have AI governance. The reason behind it is that generative AI has the potential to solve a lot of problems. They have the potential to reduce the cost, have some major business impact, as well as make some effective decision making and content creation. But the real issue over here is that there are lots of key challenges when you want to deploy this kind of AI applications. There are problems with security, there are problems with scalability, and also it's quite slow and costly. And what is really required in order for these challenges to be fixed? We want a secure and compliant AI that is being protected within the cloud, fast and scalable deployment, which is quite cost effective, and as well as it is enterprise ready. And the most important thing is trust and governance, which ensures transparency and accuracy. And this brings us to our application at Zühlke, which is called ZAG. Probably you can already imagine where the ZAG term came from. It actually came from the word RAG. So ZAG is Zühlke Augmented Generation. Think of ZAG as like an AI, which can be treated as Ask a document, where you can ask questions related to your document that you ingest into this application. But other than using one LLM, we use multi-agent approach, where it can communicate with different agents in order to answer your questions. ZAG was originally deployed in Azure cloud platform previously at Zühlke, and then we have combined our forces together to port it to AWS infrastructure. There are several key points that I want to mention about ZAG. It generates values because of the scalable architecture and the successful deployment that we had over the months. The data security is pretty good because everything that you do in ZAG is in your own cloud tenant. It is highly configurable, which is the most important feature for ZAG. That is, you can change ZAG according to your use case and according to the data that you have. And last but not the least, the high standards that it has, because everything is done in infrastructure as code, and the resilience was done through service reliability engineering. We have also used ZAG Accelerator in one of our customer projects, which is Unica. So the challenges that Unica had is the sales agents had spent too much time answering the complex questions manually. The responses were really inconsistent, and most of the time what they faced is that the customers were not really happy with the responses. They needed something where the sales agents could respond something fast, accurate. And also the sales agent finds it difficult it gets really difficult for them to access those the conversation that they had previously with those customers. How we solved it? We deployed multi-agent chatbot ZAG. We acted it as an accelerator, and then we adapted this ZAG platform into their use case and into their data. The delivery was instant, and it was the responses were context-aware responses via a very simple web interface. And the questions that the sales agent or the customers were asking to it, the accuracy was pretty good, about 95%, because it had the capability to cite those sources from where it's getting the information from. What was the impact? The impact was 50% in reduction in time and effort for the sales agent, and the net promoter score was almost 80%. The response time was significantly low. It was around 5 to 6 seconds, and which greatly improved the customer experience quite a lot. And the return on investment success was pretty good, which was informed by Unica at the end of the presentation. Now I would like to switch to my other screen to show you the ZAG demonstration. Let me know if you can see my screen.
Yep. See it.
Yep. Perfect. For the purpose of this demo, we just used a very simple, insurance documents of Zühlke. There is no really, we didn't use the actual documents. Obviously, we just used some sample documents for the demo to work. So I would add one more information. The documents that we have uploaded over here are completely German documents, but my questions will be most of the time in English. So we can start by asking. So what will happen when I press enter? So there are two models over here. One is Cloud Sonnet 3.5 and Cloud Sonnet Haiku. So I have selected Cloud Sonnet 3.5 for the answers to be generated. So when I press enter, it's going to tell me the documents that has been ingested inside this ZAG applications, and it will let me know what kind of information I can get from this chatbot. So probably we can dive into the information. For example, if you want to ask a question, am I insured if I have water damage in the building? As you can see, I have 3 insurance documents, which is travel insurance, building insurance, and valuable insurance. So we can go with this question, and let's see what it has to respond. So what it does in the background is that it checks the chunk documents that it has in the vector database, and then try to get those documents and create a meaningful answer out of it, including the citation. I hope the citation works. Let's see. Oh wow, yeah, it works. So as you can see, Claude did a very deep analysis of the question that I made according to the document information that it has inside the database. And not only that, it created a cited link where you can go and check where you got the information from with the highlighted section. So it was C2, C2.3. So we can go to C2. So it was in C2 and 2.3, which are where the information it got from. Probably we can ask a similar question like, okay, now I have a water damage. How can I make the claim? How can I make the claim out of it? How can I do the claim? So it uses the previous information that it had, the conversation about, the history of the conversation, and try to get the information also from the documents to get what are the process when there is a water damage and how can you make the claims accordingly. And it already tries to provide, it already provided some of the information that you need to follow up through in order to do the claim. And one interesting thing about Zag is that it also has a failsafe. The failsafe is if you ask questions which are not related to the documents, for example, tell me about lawyer insurance. So it apologized. It does not notice the lawyer insurance or legal insurance into this document list, and that's when it stops answering the questions because it doesn't have those documents. Last but not the least, that also has the capability to summarize your whole conversation. So for example, in a situation where the sales agent wants to know what kind of conversation this chatbot had with the customer so that it can deduce the next possible solution. And this summary can help the sales agent decide what kind of conversation was going through. Yeah. Now I will hand it over to Imo, who will deep dive into the architecture and as well as the AWS services that we have used for that.
Starting with users, they upload these documents. Now, in the example we showed you, we only uploaded 3 policy documents. In the real world, obviously, you'd have a lot more. Those get chopped up into chunks using something called textract, and we use just a batch process for that, and loaded into the vector database accessible to
Imo, I think the audience in the Teams meeting cannot see the slide.
We can see it here fine. Once the system is working, it runs inside an ECS container in AWS, obviously an Azure container service on Azure. And from there, you download a React application, which runs in the browser and has a conversational interface that you saw with the API of the back end. Whenever a query is launched, first thing the agent does is to fetch the embeddings from the vector database by doing a similarity search on the chunks. It then embeds those additional, if you like, it does an automatic prompt engineering and sends that enriched query to the Bedrock LLM and gets back a response. As well as being displayed to the user, that response gets stored in the database, DynamoDB, in a table, together with the response that it elicited. And if the user has any feedback, that gets stored in a separate table for later evaluation. Now, when they request a summary, the conversation history is retrieved and used to embed the appropriate pieces within the query to the large language model, and back comes the answer. That's it in a nutshell. There's several different agents involved, which Ishtiaq will explain later. In physical terms, where we deploy this to, obviously user is where they are. These are standard AWS services, S3 buckets, and the textract is invoked by our batch process. When the traffic travels from the user to the application, it goes via a load balancer, and we saved ourselves a lot of money by having just one VPC, one load balancer, and distributing across 4 different environments, which were sandbox, development, staging, and production, just by using the host header in the front. So we just had some CNAME entries in the DNS that allow us to distinguish those. And therefore, you've got 4 different services in the container service, each of which has their own separate task. And they all have access to the common services such as OpenSearch, Bedrock, and DynamoDB. How we deployed it is like this. We were already faced with an existing situation. The whole thing had been developed in Azure, so we didn't want to break that. And the way it works there is that you've got a Git mono repo, which contains all of the code and all of the Terraform infrastructure as code. Whenever something is requested to be merged into the dev branch or the main branch, and whenever it's actually merged, so you've got these 4 different situations, it will trigger a build. That's a pipeline consisting of 3 jobs. The first job deploys the Terraform, or doesn't deploy it, it tests it by planning. The second job builds the back end, and the third job builds the front end, runs all the tests and so forth. And if all of that is successful, then there's chained on another pipeline, which is either a development deployment or a prod deployment. That actually builds the stuff again, doesn't run all the tests, applies the Terraform so as to create, for example, if it's not there yet, the repository for the Docker image, and then it deploys the Docker image into that. Finally, it runs the container service to load the new version of the image, and it runs. So that's the situation we started with, and we then had to extend it into the AWS space. So we added another job here, which actually builds the Docker image for AWS, and it actually builds it in 2 different versions for different processor types. It then deploys that into the Elastic Container Registry in AWS. And finally, another build is triggered, another pipeline is triggered, which updates the container service with the new task and gets it to load the new task from there. So that's how we get it all running. The most difficult part of that was to work between the 2 different clouds. And we had a number of options for this to identify who's asking for the question, and authenticating and authorizing them. Normally, you'd use AWS login from your console. Completely impossible because, well, for various reasons, but the main one was that in AWS, the account we were using had a policy that said you can't create IAM users. So that was right out. SSO login is what you can use to use an existing portal to log in and then assume role. Again, works fine from the console, but we needed multi-factor authentication. You can't do that in the pipeline. Or you could set up access key and secret key based credentials, which again didn't work because this is one of those landing zones where the credentials last only 30 minutes. And therefore, a Zühlke colleague pointed out that there's this thing called AWS Roles Anywhere, and that seemed to be tailor-made for this job. To understand how it works, you need to understand what an IAM role does. It has a trust policy that allows people or principals to assume the role, typically from the same account or from another account, in this case from a different cloud. So besides the trust policy, we also have a permissions policy which says what you can do once you've assumed the role. I'll just skip through this because it's actually explained in the next slide, really, how this works. So what we did, because we didn't want to store any credentials in Git, obviously, we have a batch job, or just a shell script, which creates a number of things. It creates, I don't know if you can read that, a private CA certificate. You need a private certification authority to enable this. And the appropriate private key to go with that. And then you need client certificate and its key. Now, we've got all of those. We can deploy into AWS using Terraform the specific role that we want to use with its trust policy that says you can assume this role if your source principal is AWS Roles Anywhere. And it had the appropriate permission policies for the 2 services in AWS we wanted to use, and only the actions that were needed on those. All of that has to be encapsulated in a profile, which is then notified to the trust anchor, which is also deployed by Terraform, and the trust anchor is what consumes the private certification authority certificate. Once we've got all those bits, we can put the private key and the client certificate into secure storage on AWS. And the ARNs, these are the unique resource names of the trust policy, the trust anchor, and the CA within AWS. Those ARNs go into a group of variables which the pipeline can then access. So it gets hold of that. It gets hold of the 2 files, the certificate and key, and it then invokes something called the signing helper, which is an extension to to Azure pipelines developed by AWS. That passes the credentials across with the correct principal. It's verified against the trust anchor, and temporary credentials are provided, and that's how it works. Over to Istyak for the next bit.
Yeah, perfect. Thank you. So after all of this, we try to explore a little bit further into that. For example, the most important model or the most talking model that goes around the social media is DeepSeek. And what we did over here, maybe I can show you at first. So as I mentioned previously in my presentation, that we have multi-agent approach. So we have this on top level, that is the router model, which uses Anthropic Claude Sonnet version 2. And then we have the 2 other very simple agents, like one which does just simple answering with some questions that you have, and the other one which uses the agentic version, which uses the agent to do the answer with references. And the last one that you see summary is actually triggered from the system. So all of these 3 agents actually uses the Anthropic model. And I don't know whether you have noticed or not, but the response time was quite slow for a few, like with the question that we were asking. And what we did later on is to explore some ideas related to these DeepSeek models. What if we, on the top level, what if we keep Anthropic on the top level and keep DeepSeek at the bottom level, for example, for the agents? And we have noticed quite a significant performance improvement in terms of response time. On the right-hand side, you see a very small table, and Q means the number of questions that we asked. And when we use Sonnet only, we, on average, for 5 questions, we got around like 90, in total, we got around 95.20 seconds, and for the 5 questions, the other, we got around 47.41 seconds. And the improvement was quite significant, around 40 to 50% in reduction in response time. I would really love to show the demo, but I think we don't have much time in our hand, right, Demo?
I'd like to invite questions, and I'll get the ball rolling by asking, did we actually answer the question, is it LLMOps that we've done?
Yeah, that's a really good question. Actually, we are not there yet. It is very close to LLMOps. We are following all the DevOps principles that is required to actually fulfill our LLMOps goal. The only missing piece is the fine-tuning the model for the different use cases, and that will be our next steps that we can take in the future. Thank you, Emma.
Thanks. That's the end of this.